Hi, welcome back. I'm Chris Randall with Carl Robler. This module, we're going to talk about data resiliency.
Absolutely.
We want to talk about protecting your data.
Yep.
Let's dive in. To me, that's backup and restore, as well as some geo-replication scenarios.
It's backup and restore and geo-replication. Again, I use the term data resiliency because you have various scenarios where you need this resiliency. You've got user error you got to recover from. You have various corruption issues that you may have been used to dealing with in an on-premise. You actually don't have those in the cloud, but you may have archiving capabilities you need to do. You need to move stuff to multiple regions. You need your resiliency available for users to access your data in all kinds of contingencies.
Sure. So to me, coming from an on-prem DBA's view, two things you mentioned right up front are really significant. There's recovering from user error. So how do I do a point-in-time recovery, for example? Yep. Or there's the server went down, or the data center is flooded, and we've got scenarios to address each of these, right?
Yes.
Okay. So let's talk about these broken out by whether we're in a VM or whether we're using Azure SQL Database. Let's start with a VM. What are my options, and what's new and different?
Well, the first option is understand it is not different in a VM. You have attached storage as your default in a VM, so you're going to have your various drive letters, and
so back up to my E drive.
Just back up to your E drive, okay, or whatever drive you want to have, and you're done if that's as far as you want to go. You can have Azure actually do this backup for you, so you didn't have to think about it. It backs up whatever schedule that you have set up, and it's moving close away from infrastructure as a service closer to
right,
a platform as a service. But you're still in infrastructure. But you're saying, Microsoft, can you just handle the backups for me? And it backs it up to whatever location you specify.
So I noticed that option when I used the portal and created from a template.
Yes.
But if I'm going to upload my own VM, is that option available to me?
You can also do that exactly the same. You also have the choice to back up to a URL. Again, this is also available on-prem to back up to URL, and you actually may want to use this as part of a migration scenario, which we do talk about elsewhere in the book.
Mm-hmm.
But you have much larger capabilities when you back up to a URL. Is you're not limited by the size of your attached drives.
Sure.
And you may have attached drives may all be premium, and you want to back up to standard storage.
So I can get some cost savings there. Okay.
Save money.
Right.
And there's a new option available in a VM called file snapshot backups. And this is an option that's available if you instead of using attached storage, you use blobs to store your MDF and LDF and NDF files. This is particularly used for very, very large databases. You're going to use blobs for your storage. And a snapshot backup is using Azure Snapshot backup capabilities to essentially, on a schedule, using the same commands you're familiar with, backup database, backup transaction log. That backup command just creates a snapshot. So it's essentially instantaneous backup of, and this is key, it backs up all your data files and your log files every time you do a backup. So each transaction log backup is actually a backup of the full database and the transaction log, and you can do very quick point-in-time restores to any point in time. This is really designed for very large databases for when your data files are stored in blobs. For that scenario, this is a great solution.
So I know that there are going to be experienced DBAs out there who hear about this file snapshot option and think, sounds cool, how can I validate the backup? So do I have access to those snapshots to be able to restore them somewhere and test them?
Yeah, so these are snapshots you can restore to another machine in the cloud and then validate them. This is particularly used, one scenario it's used for is if I have a business case where I have these large backups and I want to do some business analysis on it for what happened in this month or this time period. I can actually restore it to a point in time on another machine, could be a lower powered machine, that I can restore it and do my data analysis independent of my transactional system that I don't want to overload.
Oh, so I mean, even though it's a new technology and it's using this cool new Azure Snapshot feature, it's just a backup. I mean, as far as SQL Server is concerned,
the backup commands and restore commands are essentially identical except for the words with file snapshot.
Okay.
And that's only during backup. During restore, you just point it to the backup. Restore doesn't even really know.
That's a cool thing.
You need the newest tools.
That's a cool thing. Right. Sure. Okay. Well, let's compare that to what happens in Azure SQL Database. Now, as I mentioned, I've created a separate course for MVA on data recovery with Azure SQL Database, and we talk about backup and we talk about restore. I found I couldn't talk too much about backup. There wasn't a whole lot to do, unlike on-prem or in a VM.
Yeah, so at all service tiers, what you get automatically out of the box is you get automatic backups. SQL Server takes a full backup as soon as you create it.
Yep.
It does a regular full backup, but in between it does differential and transaction log backups. Essentially, so at any given time, your backup is within 5 minutes of your current time. And those backups are locally redundant, and most importantly, they're geo-redundant. So
where do they go? Where are the backups stored?
They're stored in blob storage.
In my account?
They're stored in your account in blob storage in multiple blobs. So if you have any disk corruption, you've got it stored in multiple places.
Right.
Disks always have corruption.
Sure.
Things fail. So it's stored in multiple locations locally, and it's stored in a geo-redundant fashion.
Okay.
So either if your local data center is down for some reason, or if for some reason you just want to create a copy of the database in some remote region, they're available at any point in time. And you can do point-in-time restore, or you can do restore to the most recent time.
Right.
So the length of time.
There we go.
Yeah. The length of time that these backups are retained are dependent upon which tier you're in. Basically, as of today, and these limits change over time. Is if you're in basic, they're stored for 7 days, and if you're in standard, you get a large amount of time. I believe it's 15 off the top of my head, and it's 35 if you're in premium. And this is the length of time that it's retained. If you want to keep your data for a longer period of time, you need to archive it. And the current archiving technology is to create a backpack file. And the thing to be aware of when you create a backpack file is if you have active transactions occurring, you want to create a backpack from a copy that is transactionally consistent, or you want to create an archive while you're not having transactions occurring. Because it's a sequential creating the backup, so you can get inconsistencies if your database is active, or you use the backups you already have to create a copy and backup from that copy.
You read my mind on that, because I was wondering if we could create the archive from existing backups rather than touching the live system.
Yes.
Okay.
The key point about this is if you've got hundreds and hundreds of databases, don't do the archive all of them all at the same time. You will have performance issues.
Sure. So you've addressed a common question I've heard, which is, how do archive? What do I do after the 30 days is over? The other thing I want to make sure that we mention is a gotcha that I ran into while setting up some demos for a course. If I delete a server, that deletes the databases, but it also deletes all the backups of those databases that were on that server.
So first of all, if you delete a database during the time period that you have retention for your server, that database, it can still be recovered. So if you've got 7 days or 15 days or 35 days, you can recover the database. But yes, if you delete the server, everything about that server goes away.
So do be careful.
Yes.
Do be careful.
Again, there's virtually, I hate the word virtually, there's very little reason in many cases to delete a server, because it really is just a logical container that has almost nothing in it except for your administrative access, the server load firewall rules. And so there's really very little reason to delete a server.
Well, so
it takes up no resource. It doesn't cost you anything.
That was my question. Let's drill into that. I mean, if I'm a development shop and I want to be able to create lots of test and dev databases, I'm going to want to get rid of them when I'm done to save cost. But if I can leave the server up, it's certainly more convenient the next time I want to be able to create a database. It's nice to hear that it doesn't cost anything.
Almost no storage space associated with the server.
Okay. All right. So that's the backup piece.
Yes.
What about restores? To me, again, coming from decades really with SQL Server, where you really have to plan out your restore sequences carefully, it's a whole other story here.
You basically restore is in the portal. It's incredibly simple. You just basically go, I want to do a restore of my database, and it basically there's a couple depending if you're going to do it to a point in time or most recent. The place you go in the UI is slightly different. I can create a copy of a database, which it uses the same backups to create a copy. And when I create that copy, I can pick my the restore point, or I can use a point-in-time restore and say I want to restore to as of midnight last night or as of 5 minutes ago. And it's all handled in the portal, or again you can do it with PowerShell or REST API.
So we'll see what that looks like in the demo coming up in a minute. But one thing to point out is where the restore goes by default and what it's called, and that's different than on-prem SQL Server.
You do when you do a restore in Azure SQL Database, you do not restore over top of your database. Right. When you restore, you create a new database. So for a short or as long a period of time as you want, you actually have two databases. The new database has a different name than the existing database, and then you need to either essentially point the users to that, or you can do the whole rename.
Drop and rename, right. So it's important to point this out because there may be an impact on your storage quota for your particular service tier,
yep.
And then ongoing costs for storage. So be aware you can accumulate multiple copies.
And you can delete first and then restore, because deleting does not delete as long as you don't delete the server.
Don't delete the server, right?
You can delete the database and then restore the database and save your user costs.
Setting up geographic disaster recovery for important databases is easy with Microsoft Azure SQL Database. GeoDR protects workloads against disasters that impact an entire region by replicating databases between different Azure regions around the world. To set up GeoDR, click on Configure Geo Replication. The map helps me select any global location. I'm selecting a recommended regional pair, West US. Once I've confirmed the configuration, the replication starts. The portal will show when replication has been completed. And once completed, your workload is now protected from regional disasters. In seconds, we have globally replicated between regions and configured geographic disaster recovery.